Welcome back, everyone, for another deep dive. This time, we're going to be looking at a paper that proposes using trusted machine learning models for secure computation.
Okay.
It's a pretty fascinating concept. You know, could these powerful models actually act as trusted third parties?
Right.
Help us keep data private?
Yeah.
All this stuff. So let's unpack this idea a little bit, especially focusing on this concept of TCMEs.
Okay.
That's trusted capable model environments.
Yeah, so the core problem this paper is addressing is this need to interact with data from parties that we might not fully trust, while still making sure that everybody's privacy is maintained.
Yeah.
And you've probably worked with some traditional solutions to this, like trusted intermediaries or cryptography.
Right.
Things like multi-party computation or zero-knowledge proofs.
Yeah, exactly. And those can get really complex,
Right.
especially, as you scale things up.
Totally. And so that's where this idea of using machine learning models as the trusted party comes in.
Yeah.
So this paper explores this concept. It's not yet a standard practice.
Yeah.
But it has some really interesting potential advantages,
Okay.
especially in terms of scalability and being able to handle these complex computations.
Now, how do these TCMEs actually work?
Yeah.
Is it like putting like a really powerful AI, in a box?
That's a really good analogy.
Okay.
So TCMEs, they provide this constrained environment where the model operates.
Okay.
And it really limits the potential for data leakage.
Okay.
One of the key principles is this very strict control over the inputs and outputs.
Right.
So the model only has access to the specific data that it needs for a given task.
Gotcha.
And this really prevents it from revealing any sensitive information that's not necessary for that computation.
So it's almost like you're giving the model blinders.
It goes.
Can only see what it needs to see.
Right.
To do that specific job.
Exactly.
Okay.
Additionally, TCMEs are stateless, meaning each interaction with the model is treated in isolation.
Okay.
So there's no memory of previous computations.
Gotcha.
So data from one task can't be leaked or used in another.
Okay, so it's like a fresh start.
Yeah, it's like a clean slate every time.
Every single time.
Yeah.
Okay, that makes sense. Now, did the paper give any specific examples
They did.
of how these TCMEs could be used in practice?
Yeah, they outlined several potential applications.
Okay.
Even touching on some classic cryptographic problems like oblivious transfer.
Oh.
And it's really interesting to see that even in these really well-established areas, TCMEs show some promise.
Okay, oblivious transfer. Remind me what that is again. It's been a little while.
Yeah, so oblivious transfer is basically this scenario where you have a database and you want to allow someone to access one specific piece of data without revealing anything else about the database.
Right.
So they get the data they requested,
Right.
and you don't even know which piece of data they chose.
Okay, so it's really all about maintaining privacy on both sides
Exactly.
of the transaction. It's pretty fascinating that TCMEs could potentially play a role even in those classic crypto challenges.
Yeah.
Did they give any other examples?
Yeah. Yeah, they outlined some really interesting real-world scenarios where these TCMEs could be particularly useful.
Right.
So, for example, they discussed applications in privacy-preserving medical diagnosis.
Oh, wow.
Securing financial transactions.
Okay.
Even enabling private data analysis for research.
Gotcha. Yeah, those are all areas where privacy is so important, but traditional methods, sometimes struggle.
Yeah.
I'm kind of interested in the medical diagnosis example.
Yeah.
Could you elaborate on that a little?
Sure. So imagine you have a patient whose medical data is stored across multiple providers. This is pretty common.
Yeah.
It can make getting a comprehensive diagnosis really challenging.
Right. And of course, patients have a right to privacy. So they don't necessarily want all their raw data just like shared everywhere.
Totally. That's where a TCME could come in to create a secure, privacy-preserving pipeline for this diagnosis.
Okay.
So the patient's data would remain encrypted and distributed across the different providers.
Okay.
But a trained machine learning model housed within this TCME could access and analyze that data without actually decrypting it.
Wow. So the model is actually like working with the encrypted data.
Exactly.
Directly.
Yeah. The TCME makes sure that the model can only access the data in a very controlled way.
Right.
Specifically to perform those computations that are needed for the diagnosis.
Gotcha.
No one, not even the doctor requesting the diagnosis, ever actually sees the underlying patient data.
Okay, so the doctor inputs whatever parameters they're looking for.
Right.
The model looks at the encrypted data based on those parameters, and then it delivers a diagnosis.
Right.
But without compromising privacy at all.
Exactly. And because the TCME is stateless, each diagnosis is a completely isolated event.
Right.
So no data from previous diagnoses is retained.
Okay.
Which further protects patient privacy.
So it's really giving patients, more control over their own data.
Yeah.
But they can still, get this sophisticated medical analysis.
Exactly. And, we can apply this to other sensitive areas, too. Like, imagine proving your creditworthiness for a loan.
Okay.
Without revealing your entire financial history.
Right.
Or allowing researchers to analyze these valuable data sets without compromising individual privacy.
Yeah.
There are a lot of potential applications.
It's almost like changing the paradigm a little bit, right?
Yeah.
Of how we think about data privacy.
Totally, yeah.
It's not just locking it away,
right.
but is finding ways to actually use it.
Right.
Responsibly and securely.
Exactly. And the authors of this paper did a good job balancing the excitement of this technology with the need for, some caution and further research.
Yeah, they acknowledge that TCMEs are still pretty early.
Yeah.
In development.
Right.
There's a lot more work to do.
Yeah.
To ensure they're secure and reliable and scalable and all that.
Right.
It's not like a, perfect solution, but it's a step forward.
Totally.
Yeah.
Yeah, and they weren't trying to oversell the technology.
Right.
They were really inviting the research community to explore this direction and tackle these challenges.
Okay, so what are some of the challenges that they highlighted?
Yeah, one of the primary concerns is just making sure that these TCMEs are truly impenetrable.
Right.
Like, we need to be absolutely certain that malicious actors can't find a way to gain access to the data or manipulate the model.
Yeah, if you're going to trust it with this kind of sensitive information,
right,
it's got to be up to the task.
Exactly. So that means rigorous testing, formal verification techniques, ongoing monitoring.
Right.
All of that is going to be critical for building a secure, trustworthy ecosystem around this technology.
So it's not just developing the models.
It's the whole infrastructure around it.
Exactly. And the authors also emphasize careful design and implementation.
Okay.
Because even with a really sound theoretical foundation, if the TCME is poorly implemented, it can introduce vulnerabilities.
Right, right.
It's like any powerful tool in the wrong hands, or even with good intentions but poor execution, it can be harmful.
Right, which brings up, ethical considerations too.
Absolutely.
That's a whole other, can of worms.
Yeah. As with any powerful new technology, we need to carefully consider the potential societal impacts, both positive and negative.
Right.
We need to make sure that these TCMEs are used responsibly and for the benefit of all.
Yeah.
Not just a select few.
It sounds like they're advocating for a balanced approach, recognizing the potential benefits, but also the need to be careful about the ethical implications.
Yeah, they really emphasize responsible development and open collaboration,
To make sure that these things are implemented in a way that benefits everybody.
So it's not just like, here's the tech, but like, let's have a conversation about this.
Exactly.
Okay, very cool.
Yeah.
So to kind of wrap things up here, what are the key takeaways you think?
Yeah, I think the paper highlights 3 crucial points.
Okay.
First, it demonstrates the potential of these trusted machine learning models operating within these TCMEs to provide this new approach to private computation, particularly for those tasks that are too complex for traditional crypto methods.
So it's opening up new possibilities like we were talking about.
Exactly.
In healthcare, finance, research,
exactly.
all those areas where privacy is so important.
Yeah.
What's the second one?
Second, the paper really underscores the need for continued research and development.
Okay.
Because, these TCMEs are still early stage.
Right. Yeah.
There's a lot of work to be done to address the security challenges, ensure their reliability, enhance their scalability.
Yeah, it's like a call to action almost for the research community to really dive into this area.
Yeah.
Okay, cool. And then what about the third takeaway?
So the third takeaway is that, technological innovation needs to go hand in hand with thinking about the ethical implications.
Right.
We need to make sure that these TCMEs are developed and deployed responsibly with a focus on really maximizing the benefits for society.
Yeah.
And minimizing the potential risks.
I think that's such an important point.
Yeah.
Because it's not enough to just like make new tech.
Exactly.
We have to think about how are we going to use this? You know, is this actually going to benefit people?
Right, exactly.
All that kind of stuff.
Yeah.
All right, well, this deep dive has given us a lot to think about.
It has.
It's a really interesting concept, using machine learning to protect our privacy. It's both intriguing and challenging.
It is.
And as this technology develops, it's going to lead to some really interesting conversations, I think.
For sure.
About data security.
Yeah.
And the role of AI in our lives.
Absolutely.
That's for sure. Well, thanks for taking us on this deep dive.
Thanks for having me.
And to all of you listening, until next time, keep exploring, keep learning, and keep asking those thought-provoking questions.